So in a previous video, I went over using the limit operation to take a definite integral or a derivative. But what about the indefinite integral, where you can have f of b minus f of a, and that's your definite integral? Instead of having to do the limit and leave a and b and then put a and b in later, you can just have a straight up function and calculate it. So there's something called the fundamental theorem of calculus, and I'm not going to prove it or anything. It's basically just a simple statement from the modern perspective. Back in the day when they were inventing calculus, it wasn't simple at all, hence the fundamental theorem. But for us nowadays with fancy textbooks, it's really simple. Let there be a function, f of x, where the derivative of f of x equals f of x. This seems tautological, but basically it's just saying, whatever this is, if you take the derivative, you get this, all right? If this is true, then the integral from a to b of f of x dx equals f of b minus f of a. This is just what I've already mentioned several times. This right here, all of this, is the fundamental theorem of calculus. If you take away all the proofs and stuff and it's just what it's telling you, it's just this. If you have a function and another function that's the derivative of that function, then if you integrate the derivative, you get the integral. And it's just this. That's all it's saying. This is just defining what a derivative and integral are. It's saying if you have the integral, you can take the derivative. If you have the derivative, you can take the integral if they match up. Nothing fancy. There is something fancy, though, called an indefinite integral. If I just do integral without a and b of f of x dx equals f of x plus c. C is a constant. It's just a number. So notice it's f of x. See, it's up here. The indefinite integral, f of x is the indefinite integral, the antiderivative. There are an infinite number of antiderivatives for any function, f of x. This right here, the derivative, you get the integral. It's not the integral, it's the antiderivative. This is the integral, the definite integral. An indefinite integral is just, it's a similar concept. That's why we say indefinite integral. But antiderivative is a better name for it. And there's an infinite number of them because c can be any number. Now, what is this c? What is this c? Why is the c here? It's because you lose your starting point when you take the derivative. The derivative of a constant is 0. If you have d of dx, f of x plus a constant, that equals, because you can split up the derivatives, d of dx, f of x, plus the derivative of that constant. The derivative of a constant is 0 because it's never changing. The derivative is the rate of change. It's not changing. The rate of change is 0. So it just goes away. Whenever you take a derivative, that constant added on, any constant, just drops away and it's gone. It's essentially lost information. Because if c was 2, if c is 3, you get the same derivative. So you have to, when you take the integral, you have to add c back. And it can be just a c and you don't know what it is. Or you could remember that it was 2, or figure out it was 2. But that's the point. When you take the derivative, you lose that constant. So if you integrate, then there's any constant you can add on, and it's completely valid. This may not make intuitive sense, so let's do the vehicle analogy. Let's say that at time equals 2, so let's say x equals 2, my velocity equals 4 miles per hour. Let's say it's constant. Let's say my velocity never changes. So let's say I do that for 2 hours. So x becomes 4. X starts at 2 hours. X goes to 4 hours. That's a 2-hour span. During that time, I was going 4 miles per hour. Well, 4 minus 2 is 2 hours times 4 miles per hour is 8 miles. I've gone 8 miles. But how far am I from the starting point? Where did I start? Whatever spot I was at, wherever I was in the universe, from that spot, I just went 8 miles in those 2 hours. But where was that spot? Plus c. That's what the plus c is. The integral from a to b is applying the derivative. It's applying the rate of change. Velocity becomes position. I know how long I went and I know how fast I went, so that gives me how far I went. But I don't know where I started because that same velocity, that same duration, starting from any point in the universe is going to give me the same total traveled from that point. So we need to know what point we started at, and we could have started anywhere. That's the plus c. That's your intuition about plus c. Now I said before that the integral from a to b of f of x dx equals f of b minus f of a. Well, if f of x equals z of x plus c, I'm just putting z of x because I don't care what it is, whatever the function is, and then here's the plus z we added. Well, f of b is z of b plus c, and then minus z of a plus c. Well, the negative distributes, we get minus c, plus c minus c cancels, and we end up with z of b minus z of a, and there you go. The indefinite integral, the antiderivative, includes either a number that you had, that you knew was the starting point, or you just write plus c, or plus something. When you actually use it, it goes away. And you might think, well, then why write it? So that you don't make a mistake. You don't want to make mistakes now, that's bad. Remember to write plus c. Your teacher is probably going to mark you down if you don't write plus c, because you're supposed to be learning. The derivative of x squared plus c, just put the plus c in there because it doesn't matter, equals 2x, 2 times x. We did this in the other video, and then the c is constant, so it's not there. It's just this is 2x. Therefore, the indefinite integral of 2 times x dx equals x squared plus c. Just pointing it out. How do you find this? You look it up. Unfortunately, trying to find indefinite integrals, doing the actual math, that's really hard. This is stuff that you're not going to learn in high school. You're not going to learn in Calculus 101. This is really fancy stuff that involves really fancy math. I may do a video on it far in the future, but don't hold your breath. This is the one where I'm not even going to bother. I'm just going to say go look it up. I'm sorry. So like I said, there are plenty of rules. Doing indefinite integrals is not that hard for simple functions. You know, you can get as complex as you want. But there are rules. You just follow them. Smart people have already figured it out. Use those rules, figure out the indefinite integral, and away you go. But I recommend just looking them up. The rules for derivatives and integrals are just a Google away. One of my favorite sites is called Math is Fun. So feel free to type Math is Fun derivative rules or integral rules, and it's got some nice charts and tables and walkthroughs for you. But that's about it. That's what the indefinite integral is. That's the form we want to be able to just plug in numbers and get a result. So with that, I'll be seeing you.